In this video, we are going to go over weighted average cost of capital, also known as WACC. So to begin with, the formula. Here is the formula you find in textbooks online. Now, to be honest, the formula may look a little different in different places, but they're doing the same thing. They just have different letters, or they place these in different order, but it's still the same formula. In this example, what we have is the weights. These are the parts in parentheses that you see: E divided by V, P divided by V, and D divided by V. Just those three, those are the weights. That's the weighted average portion, or the weighted portion of the formula. The cost of capital portion are these other letters here: the RE, the RP, and the RD. This last piece here, we'll talk about it as we calculate, but that's just one minus a tax rate. And that is for the tax benefit you get when you use debt in your capital. Here's where they're explaining the different letters that I just went over. So as I said, the EV, PV, and DV are the weights. So EV is the percentage of common equity in the capital structure. The PV is the percentage of preferred stock in the capital structure. And the DV is the percentage of debt in the capital structure. The V represents the total value, or the capital being evaluated, the total capital being evaluated. And these are just the portions that add up to V. So E plus P plus D equals V. So everything is being divided by the total to get the weights. Then we have the component costs. RE represents the firm's cost of equity. RP represents the firm's cost of preferred stock. And RD represents the firm's cost of debt. These are going to be the rates. So they're going to be expressed as a percentage, just like these here, but these are weights and these are rates. Weights versus rate. And we'll go over these as we calculate them. And TC is just defining the firm's corporate tax rate. So what we want to do is we need to solve these numbers so we can punch them in the formula and then get the weighted average cost of capital. So let's go over the example. In this example, we have a company that has a capital requirement of $125 million. So let's assume that the company is gonna, or is interested in going into an investment opportunity or project, and they need $125 million to do so. So typically speaking, there are three forms which they can get that money: borrowing it, selling shares of common stock, or selling preferred stock. So those are the three items, or the three ways they can go ahead and raise capital. So let's say they say, okay, let's go ahead and take $60 million in debt, borrowing the money. Then we can sell some shares, some stock to the public for another $50 million. And we can sell some preferred stock. Now notice it's blank here, but since we know that this has to add this plus this plus this, we can just take the difference. So if I take the total minus the 60 million they're going to borrow minus the 50 million they're going to raise through selling common stock, that means they'll have to sell another 15 million in preferred stock to get the total of 125. So in other words, if you have 2 out of 3, you can get the third one. If you have this number and this number, you get this one. If you have this number and this number, you can get this one. Now that we have that, let's go ahead and get some of the information that we will need to eventually calculate the weighted average cost of capital. So bond price, 1,025. Now this is the market price. This is what their bonds are selling in the market. So they're selling at a premium right now. That is above $1,000, because when it's not specified, we assume the bond to have a face value of $1,000. Face value meaning also future value, meaning also par value. Those three mean the same. The coupon rate is 6%. It matures in 5 years. So the end of the bond is in 5 years from now, or it has 5 years total time left. Payments, as in months, not payments, the dollar amount, but the frequency of the payments. So every 3 months, they pay out some of that interest. We're talking about the bonds. And other information that we have here. Now we move on to the Treasury bonds rate. These are the federal bonds that we're going to use for calculating other things later. We're going to need that information. It's 3% right now in this example. We are saying that the S&P 500 is returning about 9%. The beta of the company, or the stock in the company, is 1.3. And then moving on to information about preferred stock information. Preferred stock par value, 100. That's the face value of the preferred stock, $100. The dividend rate is 2%. When it's not specified, it's assumed that is the annual rate. And then we have preferred stock price of $105. That means that even though the par value is 100 right now in the market, people are paying a little more. There's a premium on it, so they're paying 105. And the current tax rate of the corporation, or the company in this case, is 30%. So this is all the information we need, so we can start figuring out these numbers that we need to then put them in the formula and get WACC. So let's start with the weights. Let's start with the weights. You have the weights here. So on this table here, we got the weights. We got EV, PV, and DV, just like here and here. So what do? We're going to start the formula in equal sign Excel. E will be the equity, the common equity. So I take the 50 million and divide it by the V, which is the value. And we said the capital requirement is the value. And that's the total. So our weight is 40% equity. We do the same thing with preferred stock. Notice we just go in the order in which this example is set, but it doesn't have to be in that order. So we take the preferred stock, 15 million, divided by the total value, by the V, and that gives us 4%. We take debt, 60 million. Those are the dollar amounts, the total amounts, divided by the 125 million. 48%. These three add up to 100%. And we finished that part. This part with the weights, we finish it. So later on, we grab those numbers and we just put them in between in these spots here. So even though they're separated in the formula, you can calculate them at once, and we'll put them to the side for now. Let's go to the component costs. We're going to do this piece now. Find those numbers so we can put them in the formula. So let's start with debt. In this case, I know it doesn't start with debt here, but it's fine. Doesn't matter the order, because once you have the numbers, you can put them in the order you need. Now, in order to get the cost of debt, because they're going to do bonds, in this example, there's no loans or commercial lending here going on in notes. The only information I have debt is going to be bonds. So we're going to use bonds. So what we're looking for is a yield to maturity. That will be the cost of debt in this case. So the RD, which is this one here, cost of debt, firm's cost of debt. We're going to calculate using the time value money function. You can do it in your financial calculator. And we're going to find this here, the yield to maturity. That's the magic number we're looking for. That's going to give us the cost of debt, the RD. So let's get some information. How many payments a year? Well, if you go here, it said that every 3 months, it releases a payment, or they issue a payment on the bond. So if they do it every 3 months, that means they do 4 times a year. Or I can do equals 12 divided by the 12 months, right? 12 months in a year. divided by every 3 months, that's 4 times a year. So we know that now. So how many periods, how many payments there is going to happen over the life of this bond? So we know the bond is 5 years, and we know they pay every 3 months, which is 4 times a year. So if I take the 4 times a year multiplied by the 5 times a year, we have 20 periods. We're going to skip this one here because that's the one we're going to calculate at the end. So what is our present value? Now, remember, we are looking at this from inside the company. So if the company is selling the bond, they receive the money from the public. So the present value is how much they can sell the bond. In this case, 1,025. Now, the point is that it's a positive number, not a negative, because it's a cash inflow. The company receives the money. Now, let's talk about the payment. Now, the payment, it's something the company has to give out. So it's money, a cash outflow. The company is going to be paying this money to the person that purchased the bond. So it's a cash outflow for the company. So it has to be set as a negative. So we're going to put a negative up front so we can get a negative result. But then we go to the coupon rate, which is 6%, right? The coupon rate was 6%, times, we're going to put 1,000 manually. And the reason is, as I mentioned earlier, that if it's not specified, the face value of the bond, the future value, the par value, then you assume $1,000. So in order to get the dollar amount of the payment, you do the coupon rate times the face value. However, these payments happen every 3 months. So that 6% is the annual rate, not the quarterly rate, not the every 3 months rate. So we take that number and we divide it by the 4 payments a year. So every 3 months, the company pays out $15. A cash outflow, that's why it's negative. So 6% times 1,000 is $60, but that's for the year. So every 4 months, they pay out $15. So at the end of the year, the $60 have been paid. Future value, as I mentioned a moment ago, we assume 1,000 if it's not specified. Now, just like the payment, that's a cash outflow for the company. That's a cash outflow for the company that they will pay at the end of 5 years. So there'll be $1,000 negative as well. Now that we have these pieces of information, we want to calculate the yield to maturity. Now, one thing I'm going to say here, Excel is very particular in the sense that it requires every piece of information detailed to calculate the yearly year to maturity is what we want. Now, I'll say this because I'm going to do an extra step here in Excel that you don't have to do in your financial calculator, because your financial calculator would, if you have it set up right, it will do it for you. But I'll touch on that once I get to that point. So in Excel, what you do is you use the rate function. And it's going to start telling you which items they need. So here saying they need the N periods. That's our N here. So I'm going to start with that. And then it's asking for the payment, which I'm going to have to go that way, 0.15. So that is blocking it, but it's the negative $15. That's the payment that we calculated. Then it wants the present value. Same thing. You can't see it. I'll show it. Once I finish the function, I'll show these again so you can see them properly. but it's using the present value that we have there, which is negative 1,025. Then we have the future value. And we're not going to do the type because we'll assume end period unless specified. So you leave it blank, Excel will assume as end period. Now, we're not done yet because this rate that Excel calculated is for the 3-month period. Remember how we did everything? We multiply by 4, divide by 4. Well, this is giving us the interest rate for 3 months, but we need the yearly. So all we got to do is multiply by 4 to get the entire 12 months. And that is the actual yield to maturity at the yearly rate. And that right there is our RD, cost of debt. Now so time value of money functions will give you the answer. Now we're going to move on to cost of equity, which is the RE. For that, we are going to use CAPM. The CAPM formula, which is R equals risk-free rate plus beta multiplied by the market premium, which is the market rate minus the risk-free rate. Okay, and that's how we get our cost of equity in this example. This is not the only way to do it, but this is the ones we're going to use for the purpose of this exercise. So let's start here. Risk-free rate. The risk-free rate, we're going to use the treasury bond rate. We call it the risk-free rate because the federal government guarantees payment. So there's no risk, no default risk. So we take that amount plus the formula follows beta. We know the beta. But then the beta has to be multiplied by the difference of the market rate and the risk-free rate. So for the market rate, we're going to use the S&P 500 returns, which is the proxy for the market returns. It's going to be the return of the market, 9%, minus the risk-free rate, the same 3% we used a moment ago. And that is our required return that we're going to use for cost of equity, the RE. Now, to get the cost of preferred stock, we need to calculate the required return of the preferred stock. But that calculation requires us to know the dividend of the preferred stock. So let's calculate dividend first. So our dividend is going to use the par value and the dividend rate. So we're going to use these two numbers. Okay. Now all we do is we take the par value of the preferred stock multiplied by the dividend rate, and that is $2. That's what they pay dividend on the preferred stock. That's the dividend they pay on the preferred stock. Now that we have that number, we're going to get the required return on the preferred stock as a percentage. So now we use the dividend we just calculated, but we're going to divide it by the actual price the preferred stock is selling for, which is $105. Okay. And that gives us the required return of the preferred stock. So to do a recap before we calculate our WACC, which is the last step, here we did is each one of these three divided by the total. And that's how you got the weights, the percentages. Okay. For the cost of debt, we calculate the yield to maturity using the time value money functions. In Excel, we use the rate function, and you calculate it, you just solve for the Y. I'm sorry, for the I, which is the yield to maturity, using the other values that we spoke about. For the required return on equity, we use the CAPM formula in this situation to give us a required return. And then to get the cost of preferred stock, first we need to find the dividend, which is the 2% of the par value. And then we use that dividend and divide it by the actual price of sales, and that gives the required return on the preferred stock. Now we have the numbers that we need to fill in all these here. So all I'm going to do is here, EV. That's my EV there. So I'm moving the 40% in there. The RE, because now we're going to follow this order. We're not going to follow the order here. The RE, that's our RE here. So we're going to move that one there. The PV, preferred stock divided by the value. That's another weight. So that's the PV there. And then the RP. That's the last one we calculated here. That's the cost of preferred stock. Here is the weight of debt. RD is the one we calculated here, cost of debt. Now here, notice that we only have one decimal spot, but Excel recognizes the entire value there. And then here, we just got to do, just like it says there, 1 minus the tax rate, which we have there, 30%. So that value becomes 70%. Now that we have all the values under each one of them lined up the way we want it, as the formula dictates, by the way, this formula is the same as the one up here, we just solve for it. So I'm going to have the EV, E divided by V, the 40%, times the RE, plus, don't get confused, the multiplication and the plus signs, the PV, times the RP, plus the DV, times the RD, times the 1 minus tax. And your weighted average cost of capital is 6.3%, and you are done. That's what you do. You take the values, if you have to calculate and find the ones you need. And once you have the values that you need, put them in the formula and you calculate them. An extra piece of information I'm going to share with you. These last two, the cost of debt, the RD, which is the rate of debt or the cost of debt, when you multiply it by the 1 minus the tax rate, we call that the after-tax cost of debt. You see, the RD by itself is cost of debt. RD times the 1 minus T is then the after-tax cost of debt, and if you abbreviate it, ATCD. So you ever see this here? It's talking about these two have already been multiplied. So if you have that number, you do not repeat this step because it's already done for you. Just learn to differentiate cost of debt versus after-tax cost of debt. That by itself is cost of debt. This with this is after-tax cost of debt. That's it for this video. We'll see you on the next one.